Good day to you all. This is section 7.3, least common denominators. We have been talking about rational expressions. We have talked about how to decide when they're undefined, how to reduce them. We have multiplied them. We have divided them. Now we are learning the first step in adding and subtracting them. Just like with regular fractions, an expression, a rational expression, does have to have a common denominator before we add or subtract, okay? So let's talk a little bit about how to find the least common denominator, and this will make a lot more sense after you've seen some examples. First of all, you need to factor every denominator completely. It's got to be done. It has to be completely factored. Then you're going to list each different denominator factor the greatest number of times it appears in any denominator. That is, we write down every base that appears in any denominator, and then we use the largest exponent that ever appears on that base. That's something that's really hard to say in English, but it's really not that hard to do in math. And then we'll just multiply those factors together to get the LCD. Okay, find the common denominator for the given set of fractions. We're starting off with just numbers. So let's look at 1/4 and 3/16. So if we're looking for the LCD, it has to be at least 24. This is kind of the exact opposite of a GCF. For a GCF, we're looking for the largest thing that divides evenly into both of these. When we're looking for the least common denominator, we want both of these to divide into it evenly. So what I suggest that you do when you have numbers is you start off with your largest number, which is 24. And then ask yourself, does 16 go evenly into 24? And the answer is no. This is 24 times 1. Now try 24 times 2, which would be 48. And then you decide if 16 also divides evenly into 48. And the answer is yes. 16 times 3 is 48. Therefore, 48 is our LCD. If this were not it, I would have done 24 times 3 and then 24 times 4 until I found one that worked. Theoretically, you could do it with the smaller number as well. You're just going to be doing a lot more steps. It'll go much more quickly if you start with your larger number. Okay. So here we have three numbers, and my denominators are 15, 6, and 10. And I'm looking for a number that everything divides into evenly. And that's not going to happen here, not here. So let's start off with 15 because it's my largest denominator. 15 times 1 is 15. 10 doesn't divide evenly into 15. So let's try 15 times 2, which would be 30. 15 obviously divides into 30 evenly. So does 6. 6 times 5 is 30. 10 times 3 is 30. So my LCD here is going to be 30. Okay, so how do we find a common denominator when we have variables and such? Well, just like I said earlier, we have to factor first. Okay, so there's no factoring involved here because there's no addition or subtraction. But for this one, I have a GCF. I can factor out a 9. And that leaves me with a minus 5. Okay, so when we go to find the LCD, first deal with your numbers. Just pretend the a cubed and the a minus 5 aren't there. We have just the 27 and the 9. If we're looking for the LCD of just those numbers, I'd start off with 27 because it's larger. Does 9 divide evenly into 27? Yes. 27 also divides into 27 one time. So I have the 27, and I've dealt with the number part. Now let's look at the variable part. I have two different bases. I have an a base, and I have an a minus 5 base. This a does not take care of this a, or vice versa. Does not work. So these are my bases. And then what I do is I go through and I look for the largest base. The largest exponent that appears on an a, and a alone is a 3, so this gets a 3. The largest exponent that appears on an a-5 is a 1, so that stays to the first power. This is my LCD.